All right, super. Welcome to Telling Stories with Data, interactive data visualizations with D3JS. Should probably come up with a shorter title for this. My name is Dustin Ewers. As you can see, I have a bunch of contact information. If you want to, do Twitter or LinkedIn, I have a website. Additionally, all the code examples, the slides, everything for this talk is on GitHub, totally free. You can download it and you follow along if you want. Doesn't require anything other than a text editor and web browser to run. It's pretty simple. I also created a blog post for this talk, so if you want to go and refer to something I talked about, I actually have it all written down on my site. So let's see here. Today, what we're going to do is we're going to look at why we should care about data visualization. Then we're going to talk about what is D3JS, what you use it for, what it's not so good for. And then for the rest of the presentation, we're going to go through demos. And the demos are going to start with just basic loading up data and displaying it. And then eventually we're going to move into some more complex topics surrounding D3. Now it's important, all these examples build on each other. So if you need some clarification, I'll open the floor for questions at the end of each example. And please ask. If you don't understand something, just go ahead and ask a question. I want to make sure everybody's clear so they don't get lost at the end. So the first major question we have to ask is why should we care about data visualization? I mean Excel's pretty good, right? It's a big bunch of numbers. There's a couple of reasons we need, that data visualization is important. The first reason is that you can convey more information through images than through words. Like I can describe something, I can give you numbers, but at the end of the day I can give you a picture, and because humans are visual creatures, you'll be able to understand that picture much faster. As you can see, we have a description of a waterfall and we have a picture of a waterfall. Which has more information? Which can you get more out of? Additionally, in addition to being faster, images are also more clear. You can understand concepts that are difficult to understand using numbers by using images. For instance, if you have a budget proposal, like the United States budget, it's in billions of dollars. Those numbers are meaningless. But if you can use a visualization to provide a comparison between the different programs and provide some meaning to the numbers and provide context. Additionally, you can use images to tell stories. Because images can convey lots of information, you can link them together and you can have a progression of information, this image here, for instance. Or alternatively, you can use animation. If you've ever seen Gapminder, that guy, Hans Rosling, he has a lot of really good visualizations, and he tells stories by showing how data progresses over time. And finally, the biggest reason is that because you can use images to tell stories, stories also trump statistics. It's the reason why you never see a whole lot of beer commercials that use statistics, except for Sam Adams, oddly enough. But even then, it's just how many beers they have. Now, because of these three things, data visualization is great. It's the triple threat. It has all three. You have statistics, factual information. You have images to convey that that information more quickly. And you have stories, which you can use your data you can tell stories with your data by showing the progression via images. So the next question is, what is D3JS? Has anybody used the library before? That is a lot more than the .NET group. What kind of stuff have you used it for? Just to play around with? Anything in production? Charting?
Pie charts.
We have some pie charts. Maps? Okay, cool. It's definitely a lot more than the .NET group. Nobody really used D3 in the .NET group. So D3 was invented by Mike Bostock. He's currently works for the New York Times. He invented it in about 2009. D3 is based on a lot of previous libraries, like Flare, for instance. And it's available from GitHub and pretty much any package manager that, you're going to use. You can get it from NPM, NuGet, Bower, let's see, yeah, and whatever else. So there are a few good reasons to use D3. The first is that it uses standard web technologies, standard SVG, HTML, etc. You don't need to install any plugins. That was a limitation of previous libraries. Some of them were written in Java, some of them were written in Flash, and you had to install a plugin in order to use them. You don't have that problem with D3. Additionally, D3 is free, both in speech and in beer, which is kind of nice. Unlike other tools, like for instance Kendo UI is a lot of fancy charting, but it also costs a lot of money. D3 does not. And the other cool thing about D3 is it includes tools to build almost any kind of data visualization. And what we can do here is we can go to the gallery. So if you go to the D3 website, they have this thing called the gallery, and it shows all the different types of charts you can make with D3. So you have, your standard box chart, box plots, bubble charts. They have chord diagrams, which are kind of interesting. And you can do all sorts of stuff, and then you can go into the really crazy things like this, like these gears. Just like random stuff. You can do collision detection. I actually built one of these that my dog loves it. I have a video of him chasing the little dots on the screen. But it's really flexible. Pretty much anything you want to do that's data visualization, D3 can probably support it one way or the other. So all sorts of things that you can do. There's a couple of reasons why you wouldn't want to use D3. The first reason, which is not really an issue here because this is a JavaScript meetup, is that D3 can be hard. For example, I was in the speaker line at that conference, and a person walks up behind me. He's like, "Dustin, what are you doing?" I'm like, "Oh, I'm doing a talk on D3." He's like, the first thing he said was, "D3 is hard." And it is. There's a lot of different APIs and a lot going on. And the other thing about D3 is when it fails, it usually fails pretty hard. It doesn't give you a lot of clues as to what happened to it. The second bad thing about D3 is it doesn't really include any pre-canned visuals. D3 is really good for you to make things that are new. D3 is not so good if you just want to throw some data and get a bar chart out of it or a pie chart. There are better tools if that's what you want to do. The third reason that D3 is not, the third problem with D3 is that it's not really good with IE8. Now, there are ways around it. You can use different HTML elements. You can use different libraries to deal with selectors, but ultimately D3 does not support IE8 out of the box. And finally, the other not so good thing about D3 is that, and this really isn't an issue for me or most people, is that D3 doesn't really make any effort to hide your root data. Any web-savvy user can get at the data that you bind to your elements. Now, in most cases, that's not an issue because if you're using D3, you're sharing the data anyway. But if you for some reason care about that, D3 is probably not for you. The major use case for D3, where it really shines, is building complex data visualizations, usually with some form of interactivity in them. So here's a couple of examples of what you can do with D3. These are by the New York Times and probably built by Mike Bostock or people that he commands. This one is across U.S. companies' tax rates vary greatly. So depending on your political affiliation, you probably have a pretty strong opinion about what the corporate tax rate should be. But the reality is that the corporate tax rate really varies a lot, and this data visualization shows that. So as you can see, the average is in the middle here at 29%, and then you have some people who pay a lot and some people who pay a little. But what's cool is you can click this button, and then you can break it down by by industry. And you have all this information available to you. And as you can see, you can encode a lot of information in this visual, and it tells a story about the tax rates that would be really difficult to, to convey using statistics or text or descriptions. Here's another good one. This is the 2013 budget proposal. So as I previously mentioned, there's certain classes of numbers, the very large numbers, that are really hard for people to understand. Like, people are good until maybe about 100, and then things get a little fuzzy. But by using data visualization, and specifically D3 in this case, you can actually get a lot more information. You can actually get a better idea of what the budget's all about. So these bubbles here represent different departments, and as you can see, you can figure out which departments cost the most money, and maybe which departments don't get so much money, like the National Endowment for the Humanities. Poor them. And what's cool is you can click these buttons and it'll actually break it down into different categories. And then you can have different types of charts and then totals. And this is the kind of stuff you can do with D3. As you can see, it's really powerful. So, any questions about that? All right, cool. That concludes the PowerPoint portion of this talk. So to get started with D3, you download it, and I have a couple of examples. The first one is, this is the sort of hello D3 example. Just basically taking some data and loading it up. So we'll run this, and here we go. So what we're doing is we are taking some data and we're putting it in a table. No SVG, nothing fancy, data in table. So here's a question. Hans Rosling interviewed some people and asked, what percentage of adults in the world today are literate? And he gave 3 options. So the different options are 80% of people are literate, 60% of people are literate, and 40% of people are literate. Who thinks it's 40? All right. What about 60? What about 80? Well, 80 is the correct answer, actually. So a lot of people underestimate the world's ability to read, which is unfortunate. But so to build that example, first we have this is done in a basic web page. It's done with Foundation. Visual style is not terribly important. So what we have here is we have a table element, and we have a table body. I threw an ID on there, so it's easier to select. So if we go over to the JavaScript, we have some data, and we just take a standard object data set, nothing fancy at all. D3 is pretty good. It can actually load data from a variety of different formats. You can do tab spaced files, you can do CSVs, you can do, I personally like using Web API. JSON's an option too. So to get started, what we're going to do is we're going to go D3, we're going to go D3.select, and we're going to select the table body. So what it's doing is it's selecting that table, the T-body element. The next thing we're going to do is select all, and we're going to select all table rows. As you probably have noticed, there are no table rows. So basically what we're doing here is we're saying we are going to bind the data to table rows. And then we will eventually create the table rows later on as data comes in. The third thing we're going to do is data. And we're going to pass in our data set. What this does is it binds the data to the visualization. So it's called a selection. And then the next thing we're going to call is enter. Enter is sort of a D3 event. So enter occurs whenever new information comes into the visualization. So as each of those data elements is loaded, enter will be called. Then after that, we're going to handle the enter event by appending a table row, and then we are going to set the HTML of that table row, and we're going to print out the table cells. And we're going to pass in a function that takes the data point as a parameter. So you can use the data point up here, down here, to fill in our table rows. And this is the basic D3 pattern. It's select, data, enter, append. Any questions? All right, moving on. The next thing I want to talk about is SVG. I'm not really super great at SVG, but we need to know just enough to get through this demonstration. So let's see here. SVG is an HTML-like language that's used to define graphical elements. It is the most popular way to use D3. So you basically bind data to SVG elements. You don't have to use SVG when using D3. I think there's usages where people have used Canvas with D3. You can use standard HTML elements like we did in the first example. But in general, we use SVG. And there's a few things about SVG that are important. One, you can use percentage widths and other relative widths and heights to define SVG elements. SVG can be made responsive. And let's see here, SVG can also be styled. So if we look at our code here, you see you have some styles that apply to the SVG elements. And additionally, SVG can you can tie events to it. So you can add like click events, for instance, onto SVG elements. So the three SVG elements we defined were the circle, the little group of rectangles, and the text. So to build those, what you do is you start off with SVG. You define the width and the height of your SVG element, and then you fill the SVG with the different items. So in this case, we have a circle. So we define CX, CY, and R, which are center X coordinate, center Y coordinate, and radius. One important thing about SVG is that the coordinates 0, 0 are in the top left corner, which is pretty counterintuitive, especially when you're building data visualization, so you have to flip your visualization around when you create it. So the second thing we have is a group of rectangles. So you can see the rectangles. These respond to the size of their container. And as you can see, we used percentage width and height to define them. And we also applied a class, just like normal HTML elements. And we used the rect element and X and Y to determine the placement of those rectangles. Additionally, we also have the G element. G stands for group. So G is used in visualizations to group elements together. It's just a container, kind of like a div, really. And then the final element I'm going to talk about is the text element. So the text element, you define the coordinates, and then in the element you define your text. And you can style this just like any other text. One thing that's important about styling SVG elements is that SVG attributes in CSS are often different than HTML attributes, so you're going to want to prefix your SVG styles with the SVG elements so you don't mix things up. Any questions on SVG? I'll take that as a no. So let's see here. The next thing we're going to do is we're going to handle data events. Actually, we're going to look at scales and axes, sorry. So when building visualizations, you often want to be able to create scales and generate the axes for those scales. And D3 has a lot of helper methods to assist you in that endeavor. So there's three basic types of scales in D3. The first are quantitative scales, like for instance we have a linear scale here. These deal with numbers and are controlled by mathematical functions. The second type of scale that we have in D3 is called an ordinal scale. Ordinal scales deal in categories, so like placements in an array, or different categories like your favorite breakfast cereal, freshman, sophomore, stuff like that. And then the final type of scale that you can use is a time scale, which clearly deals with time. And in order to draw your scales out, D3 has helper methods called axes. So you can take your scale, you can generate it, and then place that into an axis, and then D3 will actually generate all of the SVG elements that you need in order to render that. So for example, it creates this axis group here, and then it creates all the different tick marks and other things within that element. So you don't have to do any of that manually, which is nice. And in order to generate those, you go to... So I have some data, just an array of numbers and an array of dates. And then what I'm going to do is I'm going to define the height and the width of the SVG element that I'm going to create later. And I'm going to define the 3 scales. So in D3, you create a scale by going d3.scale. And then in this case, we're going to build a linear scale. Linear scales just go from directly map one group of numbers to another. So we do .linear, and then we define the range and domain. The domain, or the range, is actually the output, so the range of values that you want your scale to generate. And then the domain is defines the min and max inputs. So in this case, we're defining it as 0, and then we're defining it out to the height of the visualization, -10, to give it a little bit of padding. And then we define the domain as 0 through the maximum element. And we use d3.max, which is just a standard helper that returns the maximum value in an array. And then the last function we have here is called nice. Nice actually rounds out your numbers for you. So, for example, if we go back here and look at this, as you can see, these are really, really hideous and can potentially cause anti-aliasing issues. But if you use nice, they're not so bad. They round them off for you. So to define an ordinal scale, d3.scale.ordinal, and then you put in your domain, and your domain is actually the range. So in this case, what we're going to build is an ordinal scale for the array. So we just go d3.range, which creates a range, and then we pass in the length of the array. And then we do range bands. So D3 will calculate the different bands for you, the different sizes of the, or the different spacing you need for each ordinal item automatically for you. And there are some parameters here. This is your range of values. You can also add in padding, and you can add padding on the outside as well. And then the final scale is the time scale. So d3.time.scale, which is not like the other two, but whatever. And for the domain, we're going to input the min and max date. And it's important with this to have actual date objects. D3 claims that they'll coerce the dates in whatever you put into a date. The documentation lies. I didn't have any luck with that at all. Let's see here. And then you define your range just like the first example. So to create an axis, you do d3.svg.axis. This is a function that's going to generate an axis for you. You pass in your scale, and then there's all sorts of configurations or configuration elements that you can do. Like, for instance, we have orient, and orientation determines where the numbers show up compared to the rest of the line, and you have left, right, up and down, or sorry, top and bottom. And you can also define the number of ticks. The ticks are these little guys right here, these little number labels. You can usually, normally D3 will just create however many ticks it thinks you should have, but you can specify as well. Additionally, here's the axis for the ordinal scale. You can also have a tick format. The default time format for D3 is not very good, so you can format the ticks based on what you want them to be. So in this case, we do a time format, and we do month, day, year. So to use our axes, we can do a D3 select. We're going to select a div that's our container for the chart. We're going to append an SVG element to it. We're going to set up with the width and height we specified at the top. And then we are going to append a group to that. So we're going to do a group. We're going to assign a class to it. The default styling of the elements for SVG is really not very good, so you want to change that using CSS. We're going to transform, we're going to transform the axis, and then we're going to do .call. What call does is it takes a function and then passes the current selection into it. So what we're doing is we're taking our current selection and we are passing that into the generator for the linear axis. And that'll actually build out all of the ticks and stuff for you. And then to create a label, we append a text element, And then we set some attributes to adjust the sizing and add a class. And then we set the text element here. And then we do that again for the ordinal axis and the time axis. Any questions?
Under append, I noticed they're all indented by one space. Is that because everything under append has to do with that call?
I mean, everything under it does have to do with that append call, but I think that that's probably non-intentional because it's only it's only indented a space. In the back.
We have consistent dates. The ticks are all consistent in space. If you take one out, does it create a larger gap, or does it just put them together?
I don't actually specify the dates. The D3 actually, in this case, picks the dates that it wants to put. I can specify the number, and I think there's some other tick formatting options that you can set. But in general, like for instance, there are certain scales that aren't linear. Like for instance, there's a power scale. And when you do a power scale, it'll actually space out the different items more unevenly. But in this case, these are all relatively consistent, so they space them out evenly. So, next example. So the next thing I want to talk about is updating data. In D3, we actually have 3 different data events. And I created this to demonstrate. So this is just a basic form, radius, height, and when you hit submit, you create a circle. So this is the enter event. So a piece of data enters into the visualization, and we can handle that accordingly. So let's do a bunch more. Now, as the data changes, the update event is called. So as you can see, as new elements enter the screen, the other elements scoot over to make room for the new elements. And then after a certain amount of time, I think we get about 20 of these. Here we go. So when data leaves the visualization, then the exit event is called. So as you can see, as we hit 20, the dots in front leave the visualization, they exit the stage. So to create that, we start off by creating a data set, just a standard array, nothing special. We're going to set a height and a width and an index. Now what's important is D3 is not very good about picking which elements are in the visualization, so what we do is we create an index so we can track to make sure D3 knows that that particular thing is leaving, or else D3 assumes that it's just updating the visualization. So we have our SVG, an array of colors. You can actually, they have a color scale that you can use in D3. I used to use an array here. And then when the form submits, it creates a new item, it adds it to the data set. If the data set has more than 20 things in it, it gets rid of the first one. And then it binds the data. So to bind the data, the first thing we do is we create a scale. Now remember, scale is a function that determines, that helps space things out. So in this case, we set an ordinal scale, and we create a range band with a little bit of padding. Then what we're going to do is we're going to select circles, because we're going to create circles in our visualization, and we bind the data set. And what we're going to do here is, normally D3 assumes that the index of the elements is what you should, basically identifies them uniquely. But in this case, I don't want it to do that because I want the events to actually work, so I have to specify an index. And so we're going to handle the 3 different D3 events. So the first one we're going to handle is exit. So we take our selection, and we go .exit, and that handles the exit event, kind of like .enter before. And then we set a transition. And what we're going to do is we are going to move the element off of the screen. So we set its coordinates, we shrink down the radius, we change the color, And then we set a duration. So this is going to happen over a second. So what transition gives us is a nice smooth animation, and then the duration determines how fast that animation occurs. And then at the end, we remove the element from the visualization. The second event is the enter event, which we've already seen. So what we're going to do is we're going to append a circle. We're going to place that circle in the visualization. And then we're going to actually attach a click handler to the circle. So for instance, if you click any of these circles, you actually get the information of the element that they're bound to, or the data element that they're bound to. And then for update, we actually don't specify, there is no update function. We just take the selection, we add a transition, duration, and then we set the various properties. Good? Any questions on updating data? All right.
I do have a question, actually. Do you know what mechanism D3 actually uses to keep track of when data is changing? I've used D3 a bit, but I've never actually looked into how it's actually working.
I don't know. I know that it binds the data to the actual elements, so, but I'm not sure, you know, like if it uses an event or something.
Yeah.
Like I'd assume it uses some sort of event to determine which data is updated. But in this case, we actually bind the data manually whenever the bind data is called. So we bind new data to the visualization, and then it updates accordingly.
Yeah,
So,
I was curious behind the scenes what it's actually doing. I've never bothered to look.
yeah, I didn't do...
It just works.
It's like magic, except when it doesn't work. Then it's like broken. Okay, so we're good on updating data. All right, the next thing I want to talk about is the layouts. So, as I mentioned before, D3 doesn't actually build things for you. It gives you information that you use to build things. And one of the ways D3 does that is through the use of layouts. A layout is a function that helps you generate the information used to build things. And the layout I'm going to demonstrate here is called the force layout. Now what the force layout is a group of particles, and they have gravitation. So normally there would be a whole lot of math here that you would have to do, and it'd be complicated, but fortunately D3 does all that for you. It doesn't actually build the visualization, but it gives you the information that you can use to build the visualization for yourself. And the way the layouts work is it actually binds additional data to your data set. So you can take a look at that here. So again, we have a data set. We're just going to put in some random stuff into our data set, defining the height and width, and we're going to create a color scale. This is 20 different colors. There's a couple different 10 color scales and a few 20 color scales. And they're fairly easy to use. And to use the layout, we're going to call d3.layout.force. And this actually creates the function for the layout. And then we're going to set our nodes, which is going to be our data set, a size for the visualization, and we're going to set a charge. The charge actually determines the sort of gravitation between the elements. And there's a couple of other different settings you can use in the force layout specifically to determine how the elements interact and, you know, how fast they go towards each other and whatnot. And then we're going to set a handler for the tick event. In physics-based simulations, you usually have the tick event, which occurs roughly 30 times a second. So 30 times a second, this is going to execute. And we pass in the process tick function, which will process the information, and then we say start, which starts the force layout. So then we create our SVG element using d3.select. We select a container. We append an SVG, width, height. We've done this 3 or 4 times now. And then what we're going to do is we're going to select circles. We are going to bind our data, and then we are going to enter and append our circle elements onto the screen. And then what we're going to do is we're going to do .call, and it's force.drag. What drag gives you is the ability to drag and drop with your mouse. And what we're doing is we're saying we're going to call the force layout generator, and we're going to pass in this selection. And then whenever the tick is executed, we take the nodes and we can set them to dx and dy. Now D3 generates these values for us, and so whatever D3 generates for the force layout, that's what we're going to set it to when the tick event occurs. And as you can see, we can move things around, and then D3 will automatically do the math for us, so we don't have to. There's lots of different layouts. As you notice in the gallery, there are like core layouts, and there's layouts for pie charts, and there's layouts for maps. There's all sorts of things you can do with layouts. This is just one of them. Any questions?
So what if you wanted to kind of display the math that's doing behind the scenes rather, somewhere else on the screen?
What do you mean by display the math? Like
so,
you want to have a...
you're dragging it out, it's coming back, you're positioning everything, right, according to the parameters that you specify there, so capture what is it calculating?
I don't know if you can capture the specific calculations, but you could, theoretically, on this process tick function, you could, display some of the information in the elements. So let's see here.
You can probably display the XYs of all the circles as they're being requested or something.
So as you can see here, what D3 does, it actually adds a bunch of information to your original data set, and you could display that data if you wanted to. You could also add event handlers onto, you could add event handlers on that display the information. You could have a table or something. But yeah, this is the information that it generates for you, and you could display that however you want. I don't know about the behind the scenes math, like if you want to figure out like the different parts of things, but I'm sure you could look into the library and figure it out. So that's layouts. Any questions on layouts?
Can we create custom layouts for this one, or can you import any custom layouts?
I don't know how many custom layouts there are, but I'm sure you could. I mean, actually, I'm going to go into how to create your own generators in a minute. And, in theory, you could build onto your own layouts. I mean, D3 is open source, so if you want to make your own layout, I'm sure it's possible. I'm not sure if there's any documentation on how to do so, but again, it's just math that helps you build visualizations, so you could probably pretty easily make your own if you have a particular thing. Fortunately, D3 does almost all of it does a lot of visualizations, so you're probably going to find somebody who's already done what you want to do. And you just need to modify it to your preferences. So moving on, the next example I want to show you is reusability. I mean, as you can see, all these charts require lots of specific fiddly, SVG tweaking. And it would be nice if we did not have to do that all of the time for every chart that we want to build. So here we have an example of some bar charts. We have one, and then we have another. And this is, these bar charts are actually generated using a custom generator. So let's see here. So to build your own custom generator, you expand on the D3 namespace. You create an object. So I just did D3 demos, and then I'm going to create a bar chart generator. And this is actually the pattern that D3 itself uses to build things. So by understanding this pattern, you can better understand how D3 works. So the first thing I'm going to do is I'm going to define some default width, height, various things. And I'm going to create a function. And that function is actually going to return this generator function. So we'll shrink that for a minute. And I'm going to attach to this generator function the different values. So because, JavaScript functions or objects, I'm going to append some attributes to this function object that I'm creating. So here we have these getters and setters for the different parameters. So we have width, height, etc. And what we're doing here is that if you pass in an argument, it sets the argument and returns the generator. And if you don't pass in an argument, it actually returns the value. So this is a lot like how jQuery works, for instance. And the nice thing about this is you actually chain your setters, which is what we've done in all of the other D3 examples. You see how you chain the setters, and this is how you do that. And then at the end, you return your generator function. So what we're going to do in the generator function is we are going to... here we are. This is where we're actually going to create our visualization. So what we're doing is we're passing in a selection, and then that selection has a number of data sets attached to it. So for each data set, we are going to build our visualization. So we're going to do a height and a width. We're going to define a Y scale, like we did before, using range round bands instead of range bands, which is a little different. We're going to use the map function to pick out values in the data set that we want to use in our visualization. We're defining an X scale, which is a standard linear scale, nothing special here. X and Y axis. And then we are going to select this, which is going to be the selection that we pass into the function. And we're going to append the SVG elements. We're going to generate our axes. Then we're going to generate a series of rectangles, and we're going to bind our data set to the visualization and then create our rectangles as we've done before. So in order to use this generator, it's pretty easy. The first thing we need to do is define a data set. Then we create our function, just like we did with the force layout, just like we're going to do in the next example with another layout, just like we've done with the axis. We're actually going to do d3demos.barchart. We're going to set the axis label, which is one of the parameters from up top, and that gives us our generator function. So what we're going to do is we're then going to select our element, our container, and then we're going to call datum, which is different from data. Datum actually adds the data to the selection but doesn't bind it, because we bind it in the generator function later. And then the next method we're going to do .call, which calls the generator and passes in the selection. And then because it's repeatable, we do the whole thing again in 3 lines of code and create another bar chart. Any questions on that? Do you have a question in the back? All right. So this is how you create a reusable chart. The final example I have is how to deal with responsiveness. As we all know, there's new form factors every day. People want to use their visualizations on their internet-enabled toaster, their phones, car computers, Arduinos, whatever. Not Arduinos, Raspberry Pis. Sorry, Arduino's not that good yet. So in order to do that, there's a couple of different tactics at our disposal. As I mentioned before, SVG can use relative sizing, and we could use that to create a responsive visualization. Oh, wrong. Let's go back. Here we are. But instead, what I've chosen to do here is I've chosen to use relative sizing to make the SVG fit its container. So as you can see with this pie chart, there you go. The pie chart will actually shrink according to its container. The disadvantage of this method is it doesn't really work well for text. So in this case, I actually just put the text outside of the SVG element. So in this case, we have the actual pie chart, and then we have the legend describing the different data items. So in order to build that, what I'm going to do is I'm going to build a pie chart generator. So just like before, I have different settings, and we use the getter and setter pattern that I showed you in the last example. And so we're going to use the pie layout. Pie is another layout, just like the force layout, that helps calculate the values needed to generate the visualization. So to do that, we do d3.layout.py, which creates our generator function. And in order to make our SVG responsive, we're going to use the viewbox attribute, and then we're going to use some CSS, and we're also going to use a preserve aspect ratio. So it'll actually shrink, but it'll stay proportional. So the next thing we're going to do is we're going to create an arc generator. So d3.svg.arc. This generates arcs, which are represented as SVG path elements. Now, a path element in SVG is non-human understandable. So they're defined by this D element, and this actually determines how the lines are drawn. And frankly, I have no idea how that works. And I'm thankful for D3 to help me generate that, because there'd be no way. So what I'm going to do here is I'm going to select all, and I'm going to select the groups of arcs. I'm going to append my data set and run it through the pie layout. And then we're going to enter, we're going to append a group, we're going to attach a class to that group, and we're going to move that to its appropriate location. So we're going to move the wedges to where they need to be. And then we are going to append a path element, and we'll fill it up with one of the colors. And then what we're going to do is we're going to set the D attribute, which determines how the path is drawn. And what we're going to do is we're going to pass in the arc generator that we created, which will then take the data point and then generate the appropriate mathematics and to fill the D element for us. And then we have our setters, like I showed you in the last example. And then to create that, we create our data set. We set up our generator to build our chart. And then after we build our chart, we go and build the legend based on the data, just using some standard HTML elements. Any questions about that?
Does that still work if you only have one piece of pie, so it's just one big circle?
Oh, yeah, it should work. Let's try it. Watch it not work, and then I look like an idiot. That would be...
I just did this by hand last week without D3, and that was the gotcha.
Well, let's find out if D3 can handle one wedge of pie. No, one wedge of pie. There we go.
Is it actually just a circle?
Probably not. I bet you it's an arc. Yeah, it's another arc, so it's just an arc that goes 360 degrees. So another thing we can do with the pie layout is we can actually set what's called an inner radius. So if you don't want a pie chart, and instead you want a donut chart, oops. I should probably add those elements back in too. Actually, alright, good enough. So you can have yourself a nice donut chart if you want to. So any more questions about the pie layout or responsive SVG or anything like that?
Can you do things like drop shadows, or is that not possible?
I'm not sure about the SVG, whether you could do a drop shadow, but probably. Oh, yeah, I got some nods, so seems like the answer is yes. I haven't tried. Any other questions? Well, that's all the examples I have for today. If you want to learn more about D3, go to d3js.org. There's all sorts of documentation in this lovely series of hexes that have various examples. Give it a shot. What?
Nothing. Here, sure.
Are there any books you recommend, or just go to the website?
You started the website, but the book I read was Developing Interactive Data Visualizations in D3. It's an O'Reilly book. Trying to. So I think I have a slide for that. Yeah, here we go. Interactive Data Visualization for the Web. This is the book I read. It's actually based on a series of free tutorials. It's a pretty good book. I also read Developing a D3JS Edge. That book was kind of cool for like the different patterns. Like for instance, that's where I learned about the generator pattern. That book is not as good for like basic D3. I recommend this one over that. But they were both pretty good. Back?
Have you run into having so many elements that it gets sluggish, and sluggish is
I'm sure you can have so many elements that get sluggish. I don't know if there's a limit. I mean, clearly it's a browser thing and, you know, dependent on the computer, but there's definitely potential for performance issues. Anything else? I think that's it.
Thanks.
Yeah, no problem.
You mentioned that D3 is not good for pre-canned kind of examples. Are there other tools that you use that are more just